Hello mortals, today we will unlock one of the greatest secrets of the universe. We're going to figure out how spiral galaxies form. Well, maybe not that one. It's a pretty big secret. We don't really know how these magnificent structures come to be, but astronomers are close to solving the mystery. In today's video, we'll dive into what the latest research has uncovered about the birth of spiral galaxies, and we'll see if we can help solve one of science's greatest puzzles along the way. Let's do this. Spiral galaxies are among the most majestic objects in the universe. They consist of a flat disk of stars with a central bulge and prominent spiral arms. Our Milky Way is a spiral galaxy, though because we're inside of it, we don't get to see its beauty from the outside. We have to use powerful telescopes like the James Webb Space Telescope to view our home in a new light. It's a stunning sight. At first glance, it appears as though these galaxies are static, but that's only because we're not experiencing them in real time. A typical spiral galaxy contains trillions upon trillions of stars, all of which are flying around at hundreds of kilometers per second. This creates a complex and dynamic environment where the interactions between stars and other galactic components play a crucial role in shaping their evolution. The formation of spiral galaxies remains an open question in astronomy. We don't have all the answers. What we do know comes from observations of nearby galaxies and computer simulations. It is believed that the process began around 13.5 billion years ago, when matter in the early universe collapsed to form the first stars. These early stars were massive and short-lived, but they packed a lot of punch. Their colossal size and rapid evolution resulted in the formation of vast clouds of gas and dust. As these clouds collapsed, new stars formed within them, giving rise to the first galaxies. However, something was missing. Astronomers wanted to know why these early galaxies didn't look like the ones we see around us now. Why aren't they spiral-shaped? The answer, it turns out, lies in the behavior of matter under extreme conditions. As the clouds of gas and dust came together, gravity caused them to spin. This rotation flattened the cloud into a disk shape and pulled material inward toward the center. At the same time, the fast-spinning motion generated powerful magnetic fields. These forces shaped the young galaxy into a protoplanetary disk, very similar to the disk of material that coalesced into our solar system. But there was more to come. As the disk of gas continued to collapse, pockets of high density formed, giving rise to the first stars and the building blocks of planets. This process of gravitational collapse triggered the formation of the spiral arms that define these galaxies. You see, as the material condensed in the center, it heated up dramatically. This created pressure that pushed outward against the inner parts of the disk. The result was a wave that propagated outward, much like ripples spreading across a pond after a stone is tossed into it. These waves compressed the gas and dust in the disk, triggering the formation of new stars. As the waves traveled outward, they created a pattern of expanding stellar populations. This is what we observe as the spiral arms of galaxies. But the story doesn't end there. To explain the intricate details of spiral galaxies, astronomers turned to physics. They realized that the behavior of matter under extreme conditions played a crucial role in shaping these galaxies. For example, the process of nuclear fusion, which powers stars, releases tremendous amounts of energy. This energy, in the form of radiation, exerted a force that pushed outward against the collapsing cloud of gas and dust. This outward pressure balanced the inward pull of gravity, preventing the galaxy from collapsing completely. By studying these forces, astronomers gained insights into how matter behaves under extreme conditions, pushing the boundaries of our understanding of physics. Additionally, the intense energy and radiation also played a vital role in shaping the chemical composition of the galaxies. It was responsible for the creation of elements heavier than hydrogen and helium, enriching the interstellar medium with the building blocks of life. And here's where things get really cool. As the spiral arms emerged, they didn't just expand outward. They self-organized into beautiful patterns, creating the iconic grand design spiral, or the flocculent spiral structure. The grand design spirals are characterized by their large, well-defined arms that wind gracefully around the galactic center. In contrast, flocculent spirals have smaller, more loosely wound arms that give them a chaotic appearance. It turns out that these different spiral structures arise from variations in the physical properties of the galaxies. Factors such as the strength of the magnetic fields, the amount of gas and dust, and the rate of star formation play a crucial role. For example, stronger magnetic fields tend to produce more tightly wound spiral arms, while higher gas fractions lead to more loosely wound arms. But what happens when these forces are imbalanced? What if gravity overpowers the outward push? That's where things get really interesting. When gravity takes over, the material in the galaxy collapses more rapidly and violently. This can trigger a burst of star formation, giving rise to what astronomers call a starburst galaxy. These galaxies are incredibly luminous and play a crucial role in the evolution of the universe. In a starburst galaxy, the intense gravitational forces also cause the galaxy to heat up dramatically. This heating can actually drive away some of the gas and dust, leaving behind a core of mostly stars and little gas available for future star formation. This process, known as gas tripping, can significantly impact the galaxy's ability to form stars in the future, effectively halting its further evolution. Here's the amazing thing. By unraveling the interplay of these forces, astronomers have pieced together a remarkable narrative of galaxy formation. They discovered that the spiral arms are not merely static features, but dynamic zones of active star formation. These arms act as cosmic assembly lines where new stars are born, each representing a snapshot of the galaxy's evolution at a particular moment. Furthermore, astronomers realized that these spiral galaxies are not isolated systems, but rather exist in a vast network of gravitational interactions. They are embedded in groups and clusters, and the gravitational pull of neighboring galaxies can significantly impact their structure and evolution. These interactions can trigger bursts of star formation or alter the shape of the spiral arms. Imagine two spiral galaxies in a close encounter. Their gravitational pull could distort their shapes, creating tidal tails of stars stretching far beyond the galaxies themselves. These tails contain a rich variety of objects, including globular, clusters, stellar streams, and even black hole binaries. Studying these features provides a unique window into the dynamic processes that shape galaxies over time. So you see, the quest to understand the formation of spiral galaxies has taken astronomers on a journey through the fundamental laws of physics, the behavior of matter under extreme conditions, and the intricate web of gravitational interactions in the universe. Every spiral galaxy is a testament to the awe-inspiring power of these forces and the elegance of the physical laws that govern them. Well, folks, we've reached the end of our cosmic journey to unravel the secrets of spiral galaxies. What started as a simple question about their formation has led us to the very foundations of physics and the dynamic interplay of forces that shape our universe. We've explored the role of gravity and its tug-of-war with radiation pressure, witnessed the birth of stars and the iconic spiral arms, and seen how close encounters with neighboring galaxies can create breathtaking displays of stellar motion. I hope you found this video as exhilarating as watching a time-lapse of a galaxy in its prime. Remember, every spiral galaxy is a masterpiece of the cosmos, a grand design, or a flocculent wonder. It's a place where physics pushes the boundaries, where matter dances to the tune of gravity, and where stars ignite in a never-ending cycle of birth and death. And as we continue to probe the depths of space, we'll uncover even more secrets of the universe. So keep looking up, stay curious, and who knows, maybe one day you'll find yourself at the forefront of a new discovery, unraveling another piece of the cosmic puzzle. Until then, keep exploring, keep asking questions, and above all, keep marveling at the beauty of the spiral galaxies that adorn our night sky. They are not just celestial objects, they are stories written in light, a testament to the endless wonders that await us in the grand theater of the cosmos.